Have you ever wondered how breakthrough technologies are created? The secret lies in computational thinking, a set of problem-solving skills that powers innovation. To understand computational thinking, imagine you are building a car. You start with a dream: to build a vehicle that achieves new levels of performance. But you have to start from scratch, without a clean roadmap. So, where do you start? You start with decomposition. Decomposition is all about breaking down a complex problem into smaller, more manageable parts like the engine, transmission, chassis, and so on. Think of it as a puzzle. A picture of a beautiful, sleek supercar that you want to create. This makes the problem space more simplified and easy to work with. To better illustrate this, let's look at the engine, a complex part of any car. Instead of tackling the entire all at once, we decompose it into its individual parts: the cylinders, the fuel injection system, the cooling system, etc. Each part is a smaller problem to solve, and solving each of these smaller problems helps us understand and construct the engine as a whole. For example, if you want to build a self-driving car, you decompose the problem into parts like object detection, path planning, control systems, sensor fusion, etc. Then you can solve each sub-problem separately. The same principle applies to any complex problem, not just in car manufacturing. Next comes pattern matching. You analyze existing solutions and find patterns that can be reused and optimized for your design. Identifying similarities or analogies between different problems or domains. You may borrow the basic structure of a combustion engine, but want to boost its efficiency. If you recognize a pattern, you can apply solutions that worked in the past to a new problem that exhibits the same pattern. For example, the machine learning algorithms powering facial recognition software rely on pattern matching to detect faces. The algorithms are trained on thousands of examples of human faces, allowing them to spot the pattern of a face in new images. The other key ingredient in this tech cuisine is algorithms. Developing a precise sequence of instructions for how to build each component. Creating an algorithm is like writing a recipe, with clear and ordered steps. Algorithms power everything, from web searches to robotics. Designing efficient algorithms requires logical and computational thinking. For example, Google's search algorithm, called PageRank, examines the entire web and ranks web pages by importance and relevance to a search query. It's like a virtual Sherlock Holmes. The step-by-step instructions must be articulated clearly for a computer to follow. Now, we reach a stage in our journey known as abstraction. Abstraction is about simplifying complex systems by focusing on the high-level structure, behavior, and attributes, rather than the nitty-gritty details. In the context of our car innovation analogy, abstraction is about viewing the car as a system of interrelated parts like the powertrain, the suspension, and the body, without needing to know each and every bolt and wire that holds them together. The final step in this journey is evaluation. In our car design example, evaluation could involve crash testing to ensure safety, checking fuel efficiency, and measuring performance parameters like speed, braking efficiency, and handling. It's not just about, does it work, but also, does it work well and meet all our needs? But you still need creativity. Coming up with an innovative new design requires imagination and experimentation. You try new configurations, make modifications, and improve the algorithms. With computational thinking, you can build not just a car but any complex system. From artificial intelligence to renewable energy to new medical treatments, computational thinking is the engine that drives human progress. By breaking down big problems, reusing effective patterns, developing optimized algorithms, and continuously improving designs, computational thinking makes the impossible possible. With practice, anyone can become a master builder. Practice every day. Solve some small exercises or puzzles or review examples of how others have used computational thinking to solve difficult challenges.